Hi guys, welcome to my channel Smriddhi Codes, and today we have another problem called level order traversal in a tree from Hackerrank. I have mentioned the link in the description, so do check it out. And let us now check the sample input and discuss it. So basically, as the name suggests, we are supposed to traverse this entire tree level wise. So what this means is this will be a first level. So we'll print 1 first. This is our second level. So we'll print 2 next. Then comes 5. Then comes 3 and 6. And then finally we have 4. So 1, 2, 5, 3, 6 and 4. Let us now look at the code. So if the root is null, that is there is nothing, then we'll simply return. We won't be proceeding further. But if it is not, then we'll be needing a queue of node star pointers, and in that queue we'll immediately push the root that we just passed. So we'll push the root of the tree. So while the queue is not empty, we'll be making another node star pointer called node, which will be having the address of the front of queue. So once that is done, we'll print the data of the node, and once we have printed that, we'll pop it from the queue. Next, if the left child of the node exists, then we'll push it into the queue. And the next step will be, if the right child of the node exists, then queue dot push node right. So let's consider this tree. So we first have root equal to 1. So we'll be forming a queue and pushing this into that queue. So we can see 1 is pushed. After that, we'll be entering our while loop. So while the queue is not empty, this is my node star pointer called node. Now once this is done, we'll be printing 1. This is our output. Once 1 is printed, we'll be popping it from the queue. Now let's check if now since this node has this address of 1, it's still stored in it. So if there exists a left child of node, we'll push it into the queue, but that is not the case here. We only have a right child, so that will be pushed. So 2 will be pushed. Again, we'll be making a node star pointer called node. So now print this 2, pop it. Is there a left child? No, there is not a left child. We have a right child, so that, which is 5. So we'll push that 5 into the queue. Again, node, we'll be printing this 5 next. Pop this from the queue. Does this have a left child? Yes. So that will be inserted, that will be pushed into the queue. Does this have a right child? Yes, which is 6. So this will also be pushed. Now node. Now 3 will be printed and we'll be popping it from the queue. Once that is done, we'll check for the left child of 3, which does not exist. We have a right child of 3. So pushing that into the queue. Next, 6 will be, the address of 6 will be stored in node. So after that, we'll be printing 6 and then popping it from the queue. We'll check for both left and right children of 6, which do not exist. Next, we have 4. So node, print 4, pop it, and check for both left and right children of 4 which do not exist. So we can now say that this while condition, so now we can say that the queue is empty. So now we won't be in the while block anymore. We'll come out of it, and this is our final output. So 1 2 5 3 6 and 4, and this is what was expected. So let us now code this solution. So let's now code the solution. So if the root is null, simply return we'll make a queue of node star pointers. So queue dot push root. Now entering the while loop, while node star node equal to queue dot front queue dot pop. So once we have printed the data of the node, we'll be popping it from the queue as we discussed. Once we pop it, we'll check if the left child of the node exists. So if it does, then we'll push it into the queue. Now checking if the right child of the node exists. Queue dot push. So I hope this is done. So let's now run this code. Okay, yeah, I forgot to put the closing bracket. So yeah, this was the sample test case that I discussed. And since both the outputs are same, it has passed the test case. So let's now submit this code. Great. So I hope you liked the video and found this useful. Thank you so much for watching.